Alright, we're going to continue with complex numbers, but yesterday we introduced what a complex number was. We introduced what I was, right? Which is what? If I said, what is I, what would you tell me? Square root of negative 1, good. And then I squared would be what? Negative 1, good. And we learned how to add and subtract. That was the easy part, wasn't it? That's probably the easiest out of the whole thing, right? It's just like it was a variable. I mean, you work with it as far as addition and subtraction just as if it was a variable, like you would do anything else. All right. Now, multiplication is a little bit different because when we multiply a couple of i's together, then you're going to get an I squared. You're going to have to change something. So it's not exactly the same as multiplication with just regular variables, but it's kind of a combination of the things we have learned about I and what we know already about multiplying variables together. Alright, so what I'm going to do is do a little multiplication here. And let's do two binomials. Okay, so FOIL method, right? So let's go ahead and do that and see what we get. First outside, inside last. So the first is 6. Outside is plus what? 8i. Inside is minus 9i. And then the last is minus 12, what? I squared. Now, after a while, you're going to get used to seeing, when you see an I times an I, you know it's I squared. What did we say about 10 seconds ago about I squared? It's negative 1, isn't it? So really, what's this going to be? It's going to be a plus 12, exactly. Okay, and after a while, you might not even have to write down that I squared. I'm just doing it first because we're kind of brand new at it, okay? So, but you realize what's going to happen. That's going to be a negative 1, and I'm going to show all the steps so that we don't leave anything out, okay? So this is 6. Let's add, oops, let's make it a little bit nicer. Let's add those together right there. So what's that going to be? Minus I, right? Positive 8 minus 9. Wow, it's loud out in the hallway, isn't it? Watch. I'm going to do this step. Again, this is probably an unnecessary step after a while, but I'm going to do it right now just to show you what's going on. I squared is negative 1, so I'm going to put a negative 1 right there. So when you look back on your notes, you'll say, how in the world did you get plus? It says minus. Why did you do that? And if you don't remember, you can look back at this, and that'll tell you why. Would you agree? So let's just do this. Negative 12 times negative 1 is plus 12. Again, you might have been able to get plus 12 from this step. You probably could have gone from here to here with that plus 12. And after a while, you probably should get from here to here, just doing that in your head. Does it make sense? I'm just showing you every little step so you're not confused when you look at your notes. Now remember what the form of a complex number was. Do you remember that? Using the letters? What letters did I use yesterday when I talked about a complex number? A and B, but how did I write it, a complex number? Look it up. Look in your notes. A what? No. A plus BI, right. A plus BI. That's the form of a complex number. What was the A? The what? The real number. Okay, it doesn't have to be a whole number. Okay, it just has to be a real number. It could be a fraction, could be a square root. Okay, that doesn't have to be a whole number. It could be negative. All right, but it does have to be a real number, which means it has to be on the number line somewhere. This right here is your what? If that's the real, this is the imaginary, right? And I'll just shorthand it. The big giveaway right here is that it's got an I, all right? That's the imaginary part. You got it? So the real part goes first. So what are we going to do first here? Add up the reals, right? So 6 plus 12 is 18. So that's going to go first because the real always goes first, then the imaginary goes next. And what else do I have? I don't have any other i's to add up, so what do I write? Just minus I. And that's how you want to write your answer. Okay, don't write it negative I plus 18. You understand? The real goes first, the imaginary goes second. So make sure you put it in that order. I just remember, I don't know if other teachers are real picky about the real going first, the imaginary going second or not. I remember doing this in college, though, and they were definitely picky. This one professor, anyway, was really picky about making sure the real goes first, the imaginary goes second. So let's just keep it like that. That's not that hard to figure out, is it, to do? So let's say this, all right? I'm saying it right now, so when you see a quiz or a test and I mark it wrong, you're like, what, Mr. Hammer, come on. If you write negative I plus 18, all right, I'm going to mark it wrong. Everybody got that? Because the real needs to go first and the imaginary needs to go second. Because this really is one number. It's one complex number. Okay, it's acting as one number. Even it looks like it's two separate things. It's acting as one number. So you got to make sure things are in the right place. Okay, so the real goes first, the imaginary goes second. You okay with that? All right. Okay, that's not so hard, is it? Let's do another one. Let's do this one. 6 plus 5i, and then 6 minus 5i. This is a nice one to do. This kind of looks like what? We've talked about this before. We've seen stuff like this kind of before. They're both exactly the same, except one's plus and one's minus. Difference of two squares. Right, it's the difference of two squares. Very good. Okay. So really, do you remember the... Not trick, I hate to say a trick, but do you remember what happens when you go difference of two squares? Yeah, the outside and inside add up to 0, don't they? All right, so I could just recognize that. Instead of wasting, a few seconds or whatever to do the outside and inside and add them up, you know they're going to go to 0 right off the bat. So really, I end up just multiplying the first and then what? Then the last. Just makes it a little bit cleaner, a little bit easier. Wouldn't you agree? All right, so let's just do that. And if you don't know why they add up to 0, just look at it right now. Let's do the outside and the inside. Just do it in our head. So it's 6 times negative 5i, which is negative 30i, right? Then the inside would be 5i and 6, which would be positive 30i. So negative 30i plus 30i is 0. But I know that's going to happen anyway, so I'm not even going to bother writing that stuff down. So let's just do this. Let's go 36, and then let's do the last. This is positive, this is negative. And I'm going to show every step again, all right, just until we start getting a little bit more comfortable with these things. And then 5 times 5, and then what? Is it just I or what? I squared, right, because it's I times I. You okay with this? All right, so I've got 36. What's this going to be? It's going to be a positive 25, because what's I squared equal to? It's negative 1. Negative 1 times this is positive 25. That's probably the steps. If I was to do this, I'd probably write all these steps down. I really would. Okay? I wouldn't want to take too many shortcuts, right? So there you go. And what's that? 50, 61, right? And that's it. So it's just 61. There's no I term to this at all. So it's just a positive 61. Some people may want you to write it like this, but I'm fine just writing 61. Isn't that the same thing? If you wanted to write it as a complex number, 61 plus 0i, yeah, but there's no reason to do that. This is perfectly fine. I'll just keep it like that. We good with that? All right, let's do another one. Very, very close to this. And let me see. Okay, you've done this before. The only thing different about this is we're putting the I in it. Okay? This is a perfect square, not a difference of two squares. It's a perfect square. What do? Do we just square the 4 and square the 3i? Add them up? No. What do we have to do? Multiply by itself, right? Okay, so I'm going to go 4 plus 3i. And then over here I'm going to go 4 plus 3i. And now we'll do the FOIL method. Now, does the outside and inside cancel out on these? No, okay, because they're both exactly the same. They're both positive. So there's no way I can add two positive numbers together and it cancel out, can I? As far as, right, addition. So here we go. Let's do the whole FOIL method. We get 16. Let's do this, though. See if we can do this in our head, all right? This is 12i, right? And this is going to be the exact same thing. So what's 12i plus 12i? Is it I squared? I'm not multiplying them. I'm adding them. It's 12i plus 12i. If I have 12 apples plus 12 apples, it's 24 apples, isn't it? It's not 24 apples squared. So it's the same thing here. It's just 25i, not I squared. Just 24i. You see that? I did the whole outside and inside in one shot. Plus, what? 9. Now I can go I squared, because what am I doing to these two? I'm taking 3i and multiplying it by 3i. Okay, so I times I is I squared. See that? There's a difference. If I add two i's together, it's not I squared. It's just 2i, isn't it? If I multiply two i's together, it is I squared. Let's do a little bit with this. What's this going to become? negative 1. So, again, you might be able to get away with doing less steps than this, but I'm showing you pretty much everything just so that you know what's going on here. That's a negative, so this will be what? Negative 9. Would you agree? Right? Because it's 9 times negative 1, which makes it a negative 9. Alright? What are we going to add together first? The reals, right? The reals. So 16 minus 9 is what? 7, positive 7, and then what? Plus 24i. There you go. Real goes first, imaginary goes second. Make sure you put it in that order. So really, this is not much different than what we've done before, is it? With multiplication? Yeah, pretty simple. The only thing that we've done today that's really any different is I squared becomes a negative 1. Would you agree? That's the only thing that we've done different because of the complex numbers. So for some reason, when Algebra 2, people freak out sometimes when you talk about these complex numbers and imaginary numbers. But if you just remember a couple little basic rules, it's really not all that bad, don't you think? I think it's pretty easy. Alright, let me see what else we're going to do. Alright, we'll do this thing. Let's go to a different color. Let's go with this orange right here. Now, watch. I to the first is just I. Would you agree? I'm going to make a little list here. I to the second, now you should know what that is already. We've talked about it 3 or 4 times already just today. It's negative 1, isn't it? Because it's I times I, right? Or you could look at it like this. Watch. I is the square root of negative 1, isn't it? And then if I take this and I square it, that's I squared, isn't it? What happens to the square and the square root? They cancel each other out, and you're left with negative 1. All right? We're clear on that, right? How we get that? All right. What about I cubed? What if I asked you what I cubed was equal to? Well, let's think of it this way. Okay, watch this. What's I cubed? I cubed is the same thing as I squared times I. Wouldn't you agree with that? Right? Because I to the first, right? Well, look, what do we already know? How can we simplify this? What do we already know here? We know what I squared is, don't we? So what is I squared? It's negative 1. Negative 1 times what? Just I. We're not going to break it down into square roots. We'll just keep it like this. So what's negative 1 times I? It's just negative I. Does that make sense? So I took I cubed, I broke it down into parts that I already know. I broke it down into I squared times I. Well, I squared is negative 1. What's negative 1 times I? It's just negative I. What do you think about that? Make any sense at all? Okay, let's do this. What about I to the fourth? Let's figure out what that is. That's positive 1. I'll show you why. Because I to the fourth is the same thing as I squared times I squared. Again, I like to break them down into I squareds because I know what I squared is. It's a nice little number, negative 1, isn't it? So what's I squared times I squared? Well, that's negative 1 times what? Negative 1, which is positive 1. So what's I to the fourth? It's positive 1. Let's keep going. Let's go I to the fifth. Now look, I already know you know how I've always used that I squared is equal to negative 1 because it came out real nice and easy? But look at I to the fourth. I to the fourth is even better because I to the fourth is a 1. So every time I'm going to do one of these, if I have an I to the fourth in there, I don't have to break them down into I squares now, do I? Every time you see an I to the fourth, you can just make it a 1. So I to the fifth is equal to what? Let's write it down. I to the fifth is the same as I to the fourth times what? Times I to the first. Why did I pick I to the fourth? Because I to the fourth comes out to a nice easy number that I can work with. So this I to the fourth is what? It's just 1 times I is I. Does that look familiar at all? Look, that's an I, isn't it? We'll do a couple more of these. So what's I to the 6? Let's think of this. I'll do this a little faster. So I to the 6 is I to the fourth times what? I squared. Well, what's I to the fourth? It's a 1, isn't it? What's I squared? It's a negative 1. What's that when I multiply them? It's negative 1. You see any kind of pattern going on here? Yeah. Let's do a couple more. Yep, it repeats, exactly. So I to the 7th. So when I think of I to the 7th, I think what? I to the 4th times I cubed. Well, what's I to the fourth? It's a 1. What's I cubed? It's negative 1. Okay, now if you don't remember what I cubed is, you could always take I cubed and break that down into I squared times I, couldn't you? All right, and so that's negative 1 times I, which is negative I. But you could always look up here too, right? Because I cubed is negative 1. Let's do one more. I to the 8th. Okay, what's I to the 8th if I break it down? It's I to the 4th times I to the 4th. What's that? It's 1. What's that? Times 1. Multiply them together, it's a 1. Do you see the pattern? Okay. What I want you to see is this. This is what we're going to look for. Every time you see an I to the 4th, you know that's going to become a 1. Look at this. This is I to the 8th, it's a 1. Just using this pattern, what do you think I to the 12th is equal to? 1. How did I know that? That's right. Every exponent right here that's divisible by 4 is going to come out to 1. Do you see that? So give me another one that's equal to 1. I to the what? 16th. That's equal to 1. Give me another one. I to the 20th. That's equal to 1. Agreed? You can keep on going if you wanted to. What if I had something like this, though? What if I had I to the 21st? Now, you're not going to make a chart starting with I to the 1st and then go all the way to I to the 21st, are you? Okay, that would be kind of a waste of time. So what you're going to do is you're going to think, okay, you could do this a couple ways, but I'm just going to show you how I think of it. Think of the number. Look at this exponent. Think of the number that's a little smaller than 21 that's divisible by 4. So it's I to the 20th, right? So I to the 20th. What's I to the 21st then? It's I to the 20th times what? Times I. Would you agree? Now what's I to the 20th? Since it's divisible by 4, what's that going to be? That's just going to be a 1, isn't it? And what's 1 times I? It's just I. So what's I to the 21st? It's equal to I. You get the hang of this? Let's do some other crazy ones. What about I to the 18th? Okay, what are we thinking? Now you could think of I to the 20th and go back 2, but I don't like to do that. I like to be consistent and do it the same way. Let's just go a little bit smaller. What number is divisible by 4 that's a little smaller than 18? 16. So I'm thinking I to the 16th times what? I to the 2nd, right? Because add them up, that's 18. You agree? What's I to the 16th? That's a 1. So it just cancels out, doesn't it? And then I already know what I squared is. What's I squared? It's negative 1. So what's I to the 18th? It's negative 1. Let's do a crazy one. Let's go I to the, I don't know, just give me some number. 30 what? Nah, let's do a different one. Let's go 33. Alright? Because 32nd's too easy. Because it's divisible by 4, isn't it? Alright? So what is I to the 32nd in your head? What's I to the 32nd? It's 1. Right, because 32 is divisible by 4, right? Anytime one of your exponents to the I is divisible by 4, your answer is 1. I just picked one that's not. So, but we could write it like this. I to the what? 32nd times what? I to the 1st. I to the 32nd is a 1. Times I is I. So I to the 33rd is equal to I. Yeah? What about I to the 59th power? What about that? What do you think? Okay, good. Let's go I to the 56. Alright, times what would that give you? I to the what? 3rd. Okay. What's I to the 56? Well, 56 is divisible by 4. Did you know that? Okay, it's divisible by 4, so if it's divisible by 4, that just cancels out, goes away. It becomes a 1. It doesn't go away, I shouldn't say that. It becomes a 1. 1 times I cubed. Do you remember what I cubed is off the top of your head? It's negative I. Very good. Okay, and that's it. Right? It just has that rotating, it's kind of like that circular pattern. Just keeps on going over and over and over again. You see that? Think you can handle something like that?
You can go on forever with this, just continue repeating.
Yeah. Yeah, exactly. You can do huge numbers. As long as you know what numbers are divisible by 4, it makes it really simple. Okay, let's throw in a little bit of a twist to this. What if I had I to the negative 15th? I'll start you off. Okay, this what we're going to do is this. We're going to write it as I to the 15th times I to the negative first. Okay? Because we really haven't talked about negative exponents for these, but I'm going to figure out what I to the 15th is, and then we'll figure out what this is in a second. Alright? Give me just a second. I want to see. Well, maybe I don't want to do that. Hang on just a second. Alright, I screwed up. I was thinking something completely different. What I was thinking was this. I did, but I corrected my mistake. Actually, Khan, I've been watching the Khan videos, and he makes mistakes every once in a while, and people will write in and tell him, and he'll go back and correct them and stuff like that. So it was funny though. Last night he was pretty defensive last night because people are writing in and saying he did this proof of some derivative thing, and people were saying, well, you can't do that, and they're telling all these reasons why, and he came back with another lesson that said, well, I'm getting all these people that's saying this is circular reasoning and stuff like that, and he says, I'm going to show you why it's not. And he was pretty defensive. I mean, he was like, see, I'm doing this. I'm not doing what you're saying I'm doing. This is what I'm doing. So what I'm doing is right. And he kept on going on and on. That was pretty funny. It was kind of like this hot math debate back and forth. It was pretty interesting. I was enjoying it. It was kind of cool. Anyway, let's look at this. Watch, I to the negative 15th. We could write it like this. There we go. Now that's better, right? Because you multiply the exponent. So you could do it like that. So let's figure out what this is, and then we'll take it to the negative first. We'll just take the inverse of it, basically. So what's I to the 15th? Well, I to the 15th is the same thing as I to the... Yeah, you could go 16th and go back one, but I always like to go below and then move up. Yeah, I would go I to the 12th times what? I to the 3rd, right? Or cubed. And remember, that's all to the negative first. So I to the 12th is 1, isn't it? What's I cubed? You know that is off the top of your head? It's negative I. And this is all to the what? To the negative first. So what does that mean to be to the negative first? It means you flip it down to the bottom, and so the negative still stays negative, and an I, and that's what that would be if you had a negative exponent. Doesn't matter. The negative doesn't matter if it's in the middle, the top, or the bottom. Right? Remember that from just basic math, right? Look, negative 3 over 2 is the same thing as 3 over negative 2, isn't it? Which is the same thing as having the negative right in between them. So it doesn't matter where it is. You could put it down here if you wanted to. That's fine. You could put it up here with this one or in the middle. Same exact thing, just like those are all the same thing. Okay? Let's do one more. Type. When do we get out of here? 20? Okay, I got a few minutes. Let's go this. Have we used this color today? Maybe. Look at this one. Now, we've done something like this before, but we didn't have i's, but we did have square roots. Remember back when we did stuff like this and I said simplify this? Why is that not simplified? Because you got to multiply top and bottom by the square root. Remember this? Okay, but then we shifted to something like this. We went like 2 plus the square root of 5. Now we don't just multiply the top and bottom by the square root of 5. What do? Multiply. Do you remember the fancy math word that we used? The conjugate. Good, you do remember. So we multiply by the conjugate. Remember that? Okay. In fact, again, last night watching Khan's videos, he was doing some real crazy calculus stuff that you would have no idea what he's talking about, but he actually, in one of the proofs that he did, he actually multiplied by the conjugate. There's a lot of stuff that he's doing in calculus that we learn in here that have to build up to it. You know, there's stuff way beyond it, but some of the basic stuff that he did, he would always refer back. Hey, remember from whatever, the conjugate, and he actually used this in a calculus problem. Okay, so this stuff can be used other places. So yeah, you multiply by the conjugate. Well, look at this. Well, what is an I? An I is not just a letter. It's a what? It's a square root, isn't it? Okay, it's a square root of negative 1. So how do I get rid of that square root in the denominator? Because it's not simplified with a square root in the denominator. So we multiply by its conjugate. So that would be 5 plus I. And then you do the same thing to the top. That's 5 plus I up here. Okay? That's really the only kind of new step, and it's really not even that new of a step because we've done that stuff before, haven't we? So let's see what we get now. Let's do the bottom first. Bottom's easy because when you multiply by the conjugate, the outside and the inside add up to 0. So really it's just what? 25 minus I squared. Let's see if we can do this in our head. Minus I squared. Minus I squared is the same thing as minus a negative 1, which is plus 1. Alright, do you hear what I just did right there? Okay, so I saved myself a little bit of step. Alright, let's do this one. We're going to multiply these two together. Now, we do have to multiply the outside and inside here because they're not conjugates of each other. So let's multiply it together. So what do we get? We get 15, and then let's do the outside and inside together. We get 3i plus 10i, which is 13i, and then the last is what? Let's see if we can do this. It's 2i times I, which is 2i squared, plus 2i squared. But what's plus 2i squared going to give you? It's going to be plus negative 2, right? So what's plus negative 2? It's negative. It's minus 2, isn't it? Did you see that? 2i times I times I is I squared. It's negative, so it's negative 2. All right, and we're almost done. Let's do the reals first. So that's 13 plus 13i over 26. Now we're not finished because we have to simplify. What goes into everything? 13. 13 does, right? 13 goes into 13 and it also goes into 26. Excuse me. So we have to we got to divide out a 13 from everything. You can do it a couple ways, but look, 13 into this is what? 1. Plus 13 into this is a 1. That's 1 plus I. 13 into this is 2. So that's one way to write it. If you wanted to write it as a complex number, though, let's split it up. All right, let's have a real part and an imaginary part. This is kind of like a combo. We don't want a combo. We want to split it up. So this is going to be the same as 1/2 plus what? I over 2, because both of these things are being divided by 2. So I over 2, or the best way to write it is 1/2 I. Isn't that the same thing as I over 2? So that is how you want to write the answer to this. Because why do I go through all the trouble to write it like this? Because I've separated the real part and the what? The imaginary part. Okay, so that's a complex number. Technically, I don't know. I'm pretty particular that you have the real part and the imaginary part. I want you to write it like this. Okay, it's not that hard, right? Just split it up. Just go this over this plus this over this. So write it like this. Write it like this. We good? Okay. Tell you what I'm going to do. I'm not going to give you homework tonight to do. I'll give you the worksheet tomorrow to work on. Since we're kind of out of time right now anyway, we'll go over last night's homework tomorrow. All right, so just hang on to that. And then I'll give you a new worksheet tomorrow you can just work on in class. So we won't do anything new in class tomorrow. We'll just go over last night's, and I'll let you work on today's stuff. We good?